Hello, everyone, and welcome back. So what we are going to do today is discussing the same Windows function, but from the Spark context. Like we have seen each concept from the SQL Server perspective, which is purely from the database perspective, and from the Spark SQL perspective as well. That covers the big data as well as the semi-structured or completely unstructured data, which is sitting on the file system, but you can query them and then you can apply all the transformation and all the operation like you normally do within the structured environment. So that's what we are doing so far. On both sides we are dealing, and we are trying to keep the pattern uniform, so you are not going to be overwhelmed by the large number of concepts. So we are just learning one concept and then we are applying on both sides. So the same thing in the previous video, we have seen how we can apply the Windows function in the SQL Server. Today we are going to apply the similar function in the Spark SQL environment. So obviously we're going to start from the ranking function, and then we apply the aggregation and the window swimming function as well, right? So let's because we already have discussed the initial concept, I'm just going to put the introductory video in the description. If you haven't watched that video, please watch it, where we have discussed the concept of the Windows function and how useful and how powerful they are. And it's not surprise that all the Windows function have been implemented in the Spark SQL as well, just because of their powerful nature that you can use to build some really great script that can massage the information in a efficient way. So you can see when I have used the similar data set on Spark Notebook. So let me quickly show you the employee data set. I'm just going to show you a quick sense of the data. So we have all these similar attributes, and on one more thing I just want to show to you. I think my data frame is TR, which I have actually used to build this schema. So I'm just going to print the schema of my data frame. So you can see all these attributes are same as we have seen in the SQL Server side, right? So even the schema different is not going to be different, just to keep the concept as easy as we can, because we are understanding it. Obviously, once you go and apply in the real world scenarios, practical scenarios, it's going to be a very different work item, and it really depends what kind of problem you are trying to solve. All right, so the very first thing, we're going to start with row number. If you remember, we have 4 functions. We're going to see the row number, which lie in the ranking category. We're going to see the row number. We're going to see the rank. We're going to see the dense rank, and we're going to see the NTile. And you will be surprised. The good news, all 4 functions have exactly the similar functionality within the Spark SQL. Like row number is going to allocate a unique ID to each record, right? So, and even you can see the syntax is same as well. So, and that's why I'm actually calling it record ID. I'm just calling the row number function and our class, and obviously in our class I'm doing it ordering by the organizational level. So let's see. So you can see the outcome is coming, record ID is coming in the first, and it is allocating the unique row number to each record. But one thing you realize, the organizational level is coming from low to high, and the null is not there. So that means the null behavior is different, and we can override that behavior by saying nulls last or nulls first. I haven't tried it, but let me just try it. Yeah. So nulls first is not working for somehow. Let me just put down. Yeah, it's not there. So you can see null is still coming at the end, or it might be it is not treating it as a proper null value, right? So that's another thing that I am bit I have a small doubt that it is not considering it as a proper null, and we can fix these things in our transformation that we normally apply once we prepare the data, right? So that's not a big issue. All right, so I'm just going to move it, and now what I'm going to show you, just I'm going to copy it. I'm just going to make it a bit uh, complicated just to show you how it looks like. And if we add more than one column, how it's gonna behave. So right now you can see we have all these organizational level, but the job title is not sorted. So what I'm going to do, I'm now going to order by organizational level as well as the job title, right? And in the job title, I'm just going to do it by descending, right? So let's see if we can do it. So now you can see we are getting on level 1, the vice president of sales, vice president are coming on the top. And like I mentioned, that's not the logical representation of the job title. If we want to arrange the job title within the hierarchy, we have a different techniques. We can assign the code, and based on those code, we can, you know, we can arrange the job title within the organizational level. But just for the sake of example, and obviously if I want to do it by ascending order, I just need to remove the descending, and you're gonna see the information will be changed. Now we have chief financial officer is coming on the top, and then obviously the information is sorted in alphabetical order. So pretty simple and pretty straightforward. Hopefully you will understand most of the concept because we have discussed it in detail in SQL Server. All right, so the next one is going to be the rank, and rank, like I mentioned, exactly the same thing. Even the syntax is going to be the same, and obviously the output is going to be the same. It's going to assign a value to each record, and if the record has the repetition of the column that we are using, it's going to actually allocate the same value to each record on the same against the same value. But then once it allocate a new value to the next attribute of the column, which we are using in the over clause, it's gonna skip all the values which has already been consumed from the last association to the new association. What does that what does it mean? Let me just run this query and then I'll show you. So let me just increase the size of the output. Yeah, I think that's better. So now you can see the first one, we are seeing that organizational level is coming as one is starting, and then what it does, it start allocating the same rank to all the rows which have the organizational level 1, right? So all the way till the last one, and you can see in here that it has allocated the rank 1 to vice president of sale, which is sitting on the level 1, like on the topmost level below the CEO, right? Now, once it start the next level, which is 2, it's not going to allocate 2 because it has skipped all those ranks which it supposed to allocate, but because it was on the same level, it just skipped those and allocate the same value to the rank. So you can see 1 2 3 4 5 6, so 6 values are going to be skipped, and it's going to allocate 7 as a rank value to the next value of the column which we are using in the over clause, right? So now let me open that as well. I'm just going to, so you can see our business entity order has been disturbed because we are sorting by the organizational level, right? So but if we want to allocate a sequence to this output, we can still do it. So in the next run, we're going to actually do that. So you can see, although our business entity ID sequence has disturbed, but we still have a unique value is assigned to each record in the outcome, and obviously the rank ID is behaving as it's supposed to behave. Right now, obviously, that if we don't want that to be happen, if we want to allocate rank number 2 to the next value of the organizational level, in like if you remember in the ranking function, we discussed that we can use the dense rank, because what dense rank does, it allocate the same rank on the same value of the column, and as soon as it moves towards the next value of the column, it allocate the very next value of the rank, instead of skipping all the values in between two ranks. So as a practical demonstration, you can see I'm just going to now change it. Let me see, is there any difference between in here? No. So what I'm going to do, I'm just going to change it to the dense rank, and I'm going to call it dense rank, right? All right. So let me run it. And you can see in the output, like both outputs on the screen. So it's easy to understand both ranking function in a very clear way. Like you can see in the rank function, the next rank is going to be 7. In the dense rank function, the next rank function is going to be 2. So that's the difference between a normal rank and the dense rank. So we have seen three different ranking function with the over clause. In the over clause, we can definitely specify the column name with which we wanna do the ranking. All right, so I'm just going to make it a bit complicated. Like I'm again going to now introduce in the dense rank, I'm going to introduce the job title column. And I'm going to run it, and now you will see the behavior. It's going to be now even split the dense rank based on the combination of these two columns. So you can see now as soon as the organizational level and job title combination is going to be changed, it's going to allocate a new rank, right? But if the title and the organizational level is going to be the same, the dense rank is going to be the same until unless we have a new combination, and then it allocate the next available value in the sequence from to the dense rank column. And I'm going to show it to you. So vice president, obviously our top level, we have less people in the similar rank, but as soon as we go down, so you can see in here, so level 2 application specialists, you can see we have the dense rank as of 8 to this level. However, as soon as the combination between organizational level and job title has changed, we, instead of skipping all the values between these two ranks and allocate the next rank, it just allocate the very next value, which is obviously 9. However, if we use rank value, and I think it's good to use both side by side. So I'm just going to call it rank ID, and let me run it so you can see the difference. Oops, I forgot to put the comma. Yeah, so it's all good. Let's see. Now, yeah, so application specialists, you can see 888, and in the dense rank, we are getting the next rank as 9. However, in the normal rank, we are getting the 12 because 4 values has been skipped. So you can count it 8, 9, 10, 11, and the next value is going to be 12. So that's how the system allocate the rank and dense rank. All right, last but not the least is going to be the NTile, and like I mentioned, NTile is going to group the table into chunks, depend upon what value you are providing. So, for example, if you want to divide my table into 5 blocks, right? So what it's going to do, it's going to actually order by the organizational level, and then it's going to uniformly divide the table into 5 different groups. and allocate the ID based on that grouping. So let's run it and we'll see. Now we can see we have tile ID 1. And by the way, we have total 298 records. Let me see how many records we have in the employee tables. If I quickly go up. Here. So we have 290, right? So what I'm going to do, I'm just going to launch my calculator. And by the way, guys, I'm working on the Linux dev box, so you can see how I'm now independent of the system on operating system. Although I'm using the web browser on Linux, but obviously I can run the Azure Data Studio and I can do all the work. I can run the notebooks there, or even if I want to run the Python or PySpark, I can use the Visual Code, which is obviously a free editor with a lot of extensions available. So you can see how the development and how the cross technologies are coming into the picture and making you more and more technology independent, so you can literally focus on the problem and solve them. All right, coming back to the division of our table into 5 equal chunks. So it's going to be 58, right? So if I now come in and see my I think that's the one. So you're gonna see the last tile is going to be 5, right? So you can see we have divided our table into 5 equal chunks, and obviously each chunk has its own unique ID that I called it tile ID. Now, just on an additional extra note before we close the video with the analytical function demo, what I did, I put a sub query. I put whatever I have actually put in the last query. I just want to show you the grouping of the tiles by the tile ID. So what I did, I just actually put my previous query in the sub query, and I'm just running an outer query by counting the total in each tile. And that's the beauty of sub query, or the power that this internal query is now going to behave as a table for me. So I can even run further grouping or further analytical operation on it, right? So that acts is more like a temporary representation of the outcome, and we have all the columns which we are using internally available to the external query, right? So which is pretty simple. Like you can see, I'm just counting by tile ID. Let me run it. So you're gonna see we have 58 records uniquely uniformly distributed against these 5 tiles. So that's how we can use the Windows ranking function in the SPARK SQL. Pretty straightforward, and you can run across a SQL Server as well as the SPARK SQL without learning any additional concept. Obviously, there are some clauses. If you really go deep and do some advanced Windows analytical function, then you're gonna see the difference. But those are very rare in day-to-day operation, and you can see that how seamless the syntax is between 2 different products. So hopefully it will help you to understand writing the analytical function in the SPARK SQL. Thanks for watching, and I'm gonna see you in the next video where we're gonna run the aggregate Windows function against the SPARK SQL.